In this video, we're going to solve radical equations. Radical equations come in many types. Sometimes you will have a radical, like the square root of x, and it's set equal to a number, like 5. So you could have a radical equal to a number. Sometimes the equations look something like this. The square root of x equals the square root of x minus 3. So you have a radical equal to a radical. Or maybe you have something more complicated like the square root of x plus the square root of 2x is equal to 4. Something like that. You can have radicals anywhere, you can have numbers anywhere, and the trick to solving these is to always isolate isolate a radical. So pick any radical term and make it all by itself on one side of the equal sign and move everything else to the other side. So we're isolating any of the radicals. In the first two examples, this radical is isolated. We're good to go. We can start solving. In the second example, this radical is also isolated. We're good to go. The third example, though, you have two radicals. Neither one is isolated. They're both on the same side of the equal sign. So I would probably end up taking this positive square root of 2x and moving it to the other side of the equal sign. And then we would go about solving. So the first tip is to isolate the radical. And the second tip is to look at the index of your radical. So is it a square root? We're going to be squaring to solve. Is it a cube root? We're going to be cubing to solve. It all hinges on the index of a radical about how we're going to move through this process. So let's start with an example. We want to solve, I have one more tip for you. Number 3, it is to check your answer. Always go back, plug in your variable into the original equation and see if your answer makes sense. Often with radicals, sometimes answers appear out of thin air magically, which happens because we're squaring variables, and it creates answers that are impossible. So go back and check your answers and make sure that you know exactly what values will be solutions to your equation. So we're going to solve the square root of 5x minus 1 equal to 8. So my radical is isolated, and I have a square root, so there's a 2 right there. So that means I'm going to square both sides of my equation. So as long as you do the same thing to both sides of an equation, you're doing legal math. So the square root, we're going to square, and that property that keeps coming back again and again is when the index and the power match, you can cancel them out and you can get just plain old 5x minus 1. And then over there on the right side, 8 squared, so that's 64. Now, when we've squared, we've gotten rid of the square root, and this takes us back to an equation that we know how to solve, something that we learned way back at the beginning of the previous class. So I want to solve for x, so I'll add 1 to both sides. So I get 5x equals 65. And then I'll divide both sides by 5, because again, I want to isolate x. So x is equal to 13. So now I'll go back and check my work, just in case. So I'll be taking the square root of 5 times 13 minus 1, and I want to see if that equals 8. So I'm taking the square root of, 5 times 13, so that would be a 50, that would be a 65, minus 1, does that equal 8? I'm going to put little question marks because we're trying to figure out if they are equal. The square root of 64, does that equal 8? It does. So we have correctly solved our problem, and x does indeed equal 13. Let's try another problem. Let's take the square root of 2x plus 5, and we'll add 11 to it, and that is equal to 6. So like my tips were saying, we want to isolate a radical and then look at the index, and then again we'll check our answer at the end. So I need to isolate this radical, and to do that I need to move the plus 11 to the other side of the equal sign. So I'm going to subtract 11 from both sides. So that gives me the square root of 2x plus 5 equals negative 5. So I'm going to pause right here because we can really easily just start going through the motions every single time, isolate, square, solve, check, and just keep on going over and over again. But at some point, we're going to get an answer that does not make sense. And that is happening right here. Because we're taking a square root, we sort of defined a long time ago that when you take a square root, the answer to a square root problem is always going to be positive. So it's like saying there's a hidden plus right here, a positive square root. How can a positive equal a negative number? This sentence right here in math language is impossible. It is impossible for a square root to equal a negative number. So that negative 5, that's the clincher. It says this does not make sense. So there is actually no solution to this problem. This is one way that you can get no solution to solving a radical equation. There is another way, which we'll see later on probably. But in this case, think before you start going through the motions. If you get a negative number, pause, check it out. Does it make sense? If it doesn't make sense, then there's no solution. So we're done with that one. Let's go on to a third one. In our next example, let's let x equal the square root of 6x plus 7. So in this example, the radical happens to be on the right side, perfectly fine. It is isolated, so we're good. I look at the index, it is a 2, so that means I'm going to square both sides of my equation. So x gets squared, my radical gets squared, so that leaves me with x squared equals 6x plus 7. All right, so our whole goal of solving is always to figure out what x is equal to. Sometimes that means solving a linear equation. I'm going to scroll back up. In the first example, this was a linear equation that we solved, so we had one answer. Now that I'm down here with a quadratic equation, it's because there's x squared, I might get two possible answers. So to solve a quadratic, let's just write that, solve the quadratic, we would go back to our knowledge that we learned at the beginning of the term and solve this quadratic equation. At this point, you could use any method you like. You could complete the square if you like to. You could factor. You could use the quadratic formula, whatever it is, guess and check. You could graph. Any of those are fine. The whole goal is just solve the quadratic, whatever method it takes. For me, I want to see if I can factor this. So I'll subtract 6x and subtract 7 from both sides. So I get x squared minus 6x minus 7, and that equals 0. So let's see, can I factor this? So set up my parentheses, set it equal to 0. Let's see, so we'd put x at the beginning of the parentheses, and then say what times what is negative 7 and adds to be negative 6. I'm thinking negative 7 and positive 1 are going to work. So those two multiplied make negative 7, and when you add those, you get a negative 6. So I could just quickly check x squared plus x minus 7x minus 7. Yep, those combine to be negative 6. I'm good to go. So I use the zero product rule for this last bit. X minus 7 equals 0, so x could equal 7. And then the second set of parentheses, x plus 1 equals 0, so x equals negative 1. I have two potential answers. So I need to go back and check my answers. So it's really important working with radical equations to always check your answers. My original equation was x equals the square root of 6x plus 7. So I'll check the first answer of x equals 7. So that would be 7 equals the square root of 6 times 7 plus 7. So does this make sense? Does 7 equal, let's see, we have 42 plus 7, that's 49. And 7 does equal the square root of 49, which is 7. So there we go, we have an answer. X equals 7 definitely works. All right, let's try the next one. X equals negative 1. So negative 1, does that equal the square root of 6 times negative 1 plus 7? So let's say that we just kept rolling here and said negative 1, does that equal, let's see, so 6 times negative 1, that's negative 6, plus 7, that's 1, the square root of 1. Here's where we have a problem. Remember how we just said that square roots are always defined to be positive? The negative can't equal a positive answer. Even though there's ones involved and it looks like this might work out, this does not work out at all because of that negative value. A negative can't equal a square root. So x equals negative 1 is not a solution. So x equals negative 1, not going to work out. So our only answer, the only solution that does work, is x equals 7. So this was an example of why it's really important to check both solutions and be really careful. Don't think too fast because you could convince yourself that, oh yeah, the square root of 1 and 1, they're equal, but they're different signs. So that wasn't going to work out. All right, on to our fourth example. X equals the square root of 3x plus 7, and then we want to subtract 3. So in this problem, we have a variable over on the left side, then we have the radical, and then we're subtracting a constant. So our first step is to isolate our radical. So that means we need to add 3 to both sides so that the radical is all by itself. X plus 3 is equal to the square root of 3x plus 7. All right, now our radical is isolated over there on the right side. Second step of the problem, we've isolated. Now we need to use the index. It's a square root, so we will square both sides. So square both sides. So in my head, I can multiply out x plus 3 times x plus 3. I could write it out, or I know that the answer will be x squared plus 6x plus 9, and that will equal 3x plus 7. So the squared and the square root cancel out. All right, so what do we have here? We have a polynomial on the left side, a polynomial on the right side. The squared is the clue there to solve a quadratic. So I'm going to move all the terms to one side. So solving a quadratic means everything to one side and 0 on the other side. All right, so I am subtracting 3x and subtracting 7 from both sides. I'm going to simplify. X squared plus 3x plus 2, and that equals 0. So let's do some factoring. I think I can write these out in parentheses. And what times what is positive 2 and adds to be positive 3? It looks like I can use a plus 1 and a plus 2. So I can double check that by foiling. Now I can go to the zero product rule. X plus 1 equals 0. X plus 2 equals 0. So solve each of these little linear equations. X is equal to negative 1, and then x equals negative 2. All right, so these are our potential solutions, but like always, let's go through and check our answers. So if we start with x equals negative 1, we're saying negative 1 is equal to the square root of 3 times negative 1 plus 7 minus 3. So does the left side equal the right side? Now before we jump the gun and say, oh, well, the answer doesn't work because a negative equals a square root, don't forget that there is this extra chunk over here. There's an extra term that says subtract 3. So it is possible that this could work out. So let's try it. Negative 1, does this equal the square root of, let's see, 3 times negative 1, that's negative 3, plus 7, so that's 4, minus 3, is negative 1 equal to 2 minus 3, negative 1 equal to negative 1. Yes, that does work. So it looks like x equals negative 1 is indeed a solution. Now let's check x equals negative 2. Does negative 2 equal, question mark, square root of 3 times negative 2 plus 7, and then there's our minus 3. So does negative 2 equal the square root of, let's see, 3 times negative 2, so that's negative 6 plus 7, so that's 1, minus 3. Does minus 2 equal 1 minus 3? Negative 2 equal to negative 2. Yes, that does work out. So we actually have 2 answers for this problem. Both of our solutions did work out after checking them. Let's do one more example. And in this example, let's look at the cube root of 4x minus 3 minus 5, and that is set equal to 0. So we'll start off just like we did on the other problems. We want to isolate the radicals. So that means that we are going to have to add 5 to both sides to get the radical sign all the way on the left. So the cube root of 4x minus 3 is going to equal 5. Now the second step is that we need to make sure that we raise the power of our radical just like the index. So since this is a cube root, you undo a cube root with cubing. So we're going to cube both sides of this equation. Now luckily the right side here is a single number. It's pretty easy to cube. Just be careful if you had like 5 minus x and you had to take 5 minus x to the third power. It could get a little confusing with all those terms, so just take your time. So we have a cube root and a cube cancel each other out. We get 4x minus 3 for an answer. And then we have 5 to the third power, so it's 5 times 5 times 5, which is 125. All right, we need to solve for x. This is linear, so only one x, so there's one solution. So I'll go ahead and add 3 to both sides. because I want to solve for x. So that's 4x equals 128. Divide both sides by 4. Again, I'm solving for x. So 128 divided by 4 is going to be 32. All right, well, let's check our answer. See if it actually works. So the cube root of 4 times 32 minus 3, and then minus 5, does that actually equal 0? So I'm checking the cube root of, let's see, so 4 times 32, so is that 128 minus 3, and then subtract 5. Does that actually equal 0? So the cube root of 125, because 128 minus 3, minus 5, does that equal 0? Now we'll take the cube root of 125. Well, that's nice. The answer is 5. Minus 5, does that equal 0? Yes, it does. So that means that our real answer does work, and x is equal to 32. And let's do one more example, actually. All these problems before have had one radical sign. Let's throw in one that has two radical signs. The square root of x minus 4 plus the square root of x plus 4, and that is equal to 4. What's different about this problem is that there are two radical signs. So the first tip that I'd given was isolate a radical. So here's a radical, there's a radical. Just pick one of them to solve for. So for me, I usually just take the second one and then move it to the opposite side. So we'll be looking at the square root of x minus 4, and that's equal to 4 minus the square root of x plus 4. So what I just did was I subtracted the square root of x plus 4, subtract the square root of x plus 4 on both sides. Second step, look at the index and then use that to raise the power on both sides. So this is a square root. I will square both sides of this problem. Now, when you are squaring terms that are non-radical and then they do have radical, it's going to take a little bit of time to carefully go through that. Like the right side is going to be slower than the left side. The left side is going to be a nice and easy x minus 4 because the squaring and the square root cancel each other out. On the right side though, we need to take our time. We are multiplying 4 minus the square root of x plus 4 times 4 minus the square root of x plus 4. Now the reason why I'm writing this out is because I really want to see the foiling happen, and I want to make sure to get the right signs and the right terms and not accidentally make some errors. So as I start off, so I'll do the first, so that would be 16. Then I'll do the outer, so I'll be subtracting 4 times the square root of x plus 4. So it's this 4 multiplied by this last term. That's why there's a negative. And now I'll do the inners. So multiply these guys together. So that's another minus 4 square roots of x plus 4. Make sure to watch all of the signs. Make sure that you're getting them in the right places. It's really easy to drop one. And then lastly, we have our last term and the last term to be multiplied together. So I have a negative times a negative, which is a positive. So I look at the signs first. And then because x plus 4 is the same as x plus 4, I'm really just squaring a square root. I'm going to write out that exact thing. I'm squaring x plus 4 that is square rooted. So this turns into a nice and easy x plus 4. I'm going to cross that out just because I did the math right now. Okay, so we have a couple terms and we have a long string of terms. Let's go through and clean this up. X minus 4 equals 16 minus 8 times the square root of x plus 4. X plus 4. Because look, there's negative 4 and negative 4, so that means negative 8. And then over here at the end, we had a plus x plus 4. So these next couple steps are just going to be a matter of combining like terms one thing at a time so that I don't do too many things at once. X minus 4 is equal to 20 minus 8 times the square root of x plus 4 plus x. Okay, so at this point, it looks a little bit messy, but here's the game plan. We started off this problem with 2 square roots, which basically means that you have to square both sides once for one of the radicals, and then when you get further along, you have to square both sides again for the second radical. But to do that, we need to isolate the radical. So these next few steps are going to be spent just trying to isolate this square root of x plus 4. So I need to move everything I can to the left side because, well, the radical's on the right, so I might as well just keep it there. Isolate the square root of x plus 4 by moving all other terms to the left. So that means I'll subtract x from both sides. Okay, I'm going to subtract 20 from both sides. So I start off by doing addition or subtraction. So those go away, those go away. Hey, look, those go away too. Now I have negative 24 equals negative 8 times the square root of x plus 4. All right, I am almost there. I cleaned up a lot of terms. I do want to isolate this square root. So I notice that there's an 8 coefficient. So I can go ahead and divide both sides by negative 8. So 8 is just multiplied by the radical sign. So I can divide and do the opposite. So negative 24 divided by negative 8, so that gives me 3. So 3 is equal to the square root of x plus 4. All right, we're getting into the home stretch here. My goal was to isolate this square root. I have done that. So it's kind of like back to the drawing board. Isolate your radical, look at the index. So it's a squared. So now I will use the squared on both sides so that I can get rid of my radical sign. So 3 squared, that makes 9. Squaring a square root, that gives me x plus 4. And the goal, ultimately, is always to solve for x. So I'm going to subtract 4 from both sides. So cancel, cancel, I get 5 equal to x. All right, well, let's check that answer. Seems like x equals 5 seems reasonable. I need to go back up to the very, very beginning, way up here, written in blue, and check my answer. So we're checking, does x equal 5 work? We will take the square root of 5 minus 4, add that to the square root of 5 plus 4, and we want to check to see if that equals 4. So there we go, squeeze that in there. Let's check my math. So the square root of 1 plus the square root of 9, does that really equal 4? So 1 plus 3, does that equal 4? It does. So because 4 equals 4, we got a true statement. That means that x equals 5 is indeed our answer. So this problem is a lot longer than the rest. 2 square roots means you go through the process twice. Be careful with your signs. Be careful moving terms from one side to the other. It's really easy to forget signs. And then go back and check your work into the very original problem to make sure that you got the right answer.